So hello and welcome to the testing Python code with pytest, code Maven or Python Maven workshop. I should say Python Maven. My name is Gabor Szabo. I'm really happy to see people here in this meeting, and I'm happy if people are watching it on YouTube as well. We are already like 15 people now, and it's growing. It's very nice to see many people joining us. We're going to cover testing. I think I'm going to talk about it for about an hour or so, maybe a little bit more. Feel free to ask questions either by your voice, okay, or in the chat room. I'll take a look at the chat once in a while, so I'm going to look upwards in case you're wondering why I'm doing it. And I think that's sort of the administrative part of what we are doing here. If you're looking at the YouTube video, then please thumb up and follow the channel. No, I have to say that all the time. So let me say a couple of words about myself and about the testing. I've been programming for about 40 years now, and I've been a self-employed trainer, basically. So I do both training and consulting work for companies for almost 25 years now. During training, I used to train a lot of people programming in Perl. Then for many years, I taught mostly Python. And these days, I teach Python and Rust as well. And one of the most one of the areas that I really like is testing. And so it's quite important, and that therefore I teach these kind of courses quite often. Because I think that writing tests is one of the few extras that people can add to their programming knowledge, let's say, to make them way more valuable than other people who don't know how to do that. So let me discuss a little bit what is testing, and for that I'm going to already share the screen. I would like to show you. Just a second. I also have to focus on how I click on these buttons. Okay, so you can see the website. You're supposed to be able to see the website of Meetup, and specifically this event. So I don't know what kind of applications you're writing. Many people are writing web applications, and therefore it's a good example to show you a web application with this. But in general, the same thing applies for eventually everything. So here is the application, this website, the meetup.com. And how would the developers of that website verify that the site works? And in order to verify, the first thing that they'll have to do, I mean, they have the deployed version, right? But testing on the deployed version is not really the best idea, because preferably, you would want to verify before you deploy your code, right? So you make some changes, and you would like to verify that everything works fine before you deploy. So you will need to have some kind of an environment where you can already run these tests. You can already do your testing. So traditionally, what companies had is that they had a separate testing environment where with a lot of investment, they set up the website, and then people manually did QA on it, going around and whatever, clicking on buttons, trying to do various things. For example, let's say here I'm the organizer tools, and then click on, let's say, manage attendees or contact attendees. Okay, so let's say I wanted to check this, so I have to click on this one. Then I have to verify that I got back whatever is expected to be here, various checkboxes and the radio buttons. Then the person would fill out this form that sends out an email, clicking on the button, and then the test is supposed to verify that the emails at least were sent out to the right addresses. Okay, we can't really, maybe we can also verify that they arrived somewhere in the right place, but they have to verify that they were sent out at least. So this is a rather complex thing. For that, we have to set up the website. it has at least one database behind it. It has to configure the email sending and all kind of things. So it's a lot of investment just to set up the environment to be able to test this application, this web application. And traditionally, some system people were setting up the website for the QA department, and there were people testing there. But in our world now, when we would like to be able to deploy frequently, it's basically impossible to do these loops of testing manually. So we wanted to test automatically, meaning we wanted to have some code that will run the tests, all these things that people were testing manually. And for that, we had to be able to set up the whole system on its own automatically. And that's one of the biggest problems many companies are facing regarding testing, that they don't know, okay, in general, how to set up their whole environment. There might be documents, but it's not really well documented. There are just selected few people who know how to set up the whole environment. It might be also expensive to set up. Maybe you need some kind of special hardware in some cases, but just setting up all the database and so on, it can be time-consuming, whatever. So that would be the first thing to learn, how to be able to set up your environment before you can even test. And we can't, in this workshop, in this meeting, we can't really go that far. So instead of that, we are going to do, we're going to start as if we were starting to write an application now. And I know that for most of you, that's not really the case. You are in some company, you already have some code, some application, and now you are wondering how could you test it? And I have to tell you, it's difficult. It's difficult because one of the key parts is setting up the environment. And even if not that, even if just you're just trying to test one single function, in many cases, in many code bases, functions are interdependent, what we call spaghetti code, where each function depends on some other function, and there are circle dependencies and whatnot. So it's rather difficult to test a single function on its own. But well, that's the approach we should take eventually. So let's try to set up some basic thing. I'm going to create here a new project and start to work through it. So testing demo would be, let's say, this library. I don't really know what to do. So I'm going to create this one, Git init. I'm creating some Git repository here. So later on, I will be able to push out to GitHub. So you'll have the code. And the most basic thing we could do is create a Python module with a single function and test if that function works. So I'm creating a very simple thing, mymes.py, just some, and I'm going to use, actually, I wanted to use Visual Studio Code here. So let's try this code. Yeah, we'll have to play with it. Okay. It's opening in the other window. Okay, fine. We are here, but I didn't want to enlarge it fully. I have some issues that earlier videos, people told me that, sorry, that I both wanted to enlarge the fonts, but you won't be able to see the bottom line because of the video, or Zoom thing. So let me try to resize the window here so you will be able to see it. Okay, I don't know what's going on here. Okay, so let's create a file called mymes, and in that I'm going to even save it, mymes.py. And in that file already exists. Okay, replace it. Okay, just replace it. Apparently, I already created it. So in this one, I'm going to add just a simple function. Def add, it gets to numbers, and it is supposed to return x plus y. Okay, not very complex thing, but we are trying to see how basically the the mechanism of testing works. So I have this MyMess module. Now, how can I use this before I actually, how would you test this, okay? And people who don't know the testing frameworks would say, okay, I'm going to write some command line program that uses this function and then run that command line program. So I create a new file, which is going to be, let's say, use mymath.py. Oops, not this one, .py, right? And here I am going to import mymath, let's say, or from mymath I import the add function. And then I'm running mymath dot add and 2 and 3, let's say, and then I'm printing it out. Okay, so that's what so many people do. And then I can open this the terminal and run Python use mymath, and I don't have Python on the system, of course. So I have to start a virtual environment, and let's do it here. Virtual env minus p Python 3, and let's call it venv, and source venv bin activate. Okay, so now hopefully I have Python now, Python 3 basically mapped to this. I will be also able to install various Python modules that I need in this one. So I can run this code now, and I can look at the number 5 and say, okay, this is right. And then I would add more of these cases and say, okay, what about 2 plus 2? And that should be 4. And I could do this, and many people do this, and basically stop at this point and save, let's say, this program that will show me the result. So they will be able to run it later, but they never really turn it into an automatic test. But it's rather easy to do that once you listen 5 more minutes to me. So in order to convert it into a test, let me just copy paste the whole thing, copy paste, and I create a new file. And this file, I'm going to call it test mymath.py. Okay, and I keep pressing the slash instead of the dot. Now, in this case, I pasted this whole thing. That's not ready yet. Instead of this print out, I create a function here called test. And again, I can put here any name. Let's say test add. And inside this function, I call the mymath, just as I did earlier, and I compare it to the expected value, which is 5, right? Let me comment this out for now. So this would import the module. So if someone runs this function, then it would call the add and then compare it to 5. Now this itself doesn't do much. I need to also call assert on it. Assert is a regular Python keyword. It's nothing special to testing. It just gets basically a true or a Boolean value. So it's either true or false. And if it's true, then assert won't do anything. It will just, your code will just keep running. And on the other hand, if assert gets a false, then it raises an exception. So basically, I could have written just, this is basically the same as writing if not raise some kind of an exception, blah, blah, blah. I don't write it down, okay? So basically, the assert is just this, nothing else. And let me comment this out so it won't be bothering us. By the way, just reminder, if you have any questions, feel free to ask. You can also write it in the chat or just start speaking. Just remember that we are recording it and it's going to be published. So, right. So what we have here, I don't need, yeah. Okay. So what we have here now is a function called test add that if someone is calling it, then it will run this function and compare it to some expected value. But who is going to call this? And here is something that is surprising to many people who start writing tests. We don't have, and who are used to writing applications where they are the ones who are calling functions. In our case, we don't need to call the function, okay? It's not us that we are going to code the function, but instead of that, this pytest framework. So let me try to run pytest, and I think I won't be able because pytest is not installed. It's not coming with Python. So I start with pip install pytest, okay? It doesn't like me. I don't know why it's complaining. I think I'm in the virtual env, so whatever. Visual Studio Code didn't like what I did. So now I ran pytest, and this is the output I got. Okay, so what happened? Pytest is looking for a file called test underscore something. It doesn't matter what, but it has to start with test underscore, and of course end with .py. So that's why I called the file test underscore. You can have actually more of these files, and pytest will, and you can have a whole hierarchy of files, so subfolders, and pytest will find all of them. It's called the discovery step of pytest. Inside the test files, it is going to look for functions which are called, again, tests underscore something. We can have one or more of these functions. In this case, we had only one. And then once it finds all of these, then it will know how many of these test functions we have. And then pytest will call each one of these functions in some order. Okay, actually in the order they appear in the file. So pytest will run it, and then it will look for and wrap the whole thing in a try except block. So if this assert actually raises an exception, it won't blow up the whole process because pytest will capture that exception and report it as a test failure. We are going to see it soon, what happens then. But for now, we are on the happy path because our test actually passes, meaning that this equation, we have equality. So this expression is true. So assert doesn't do anything, doesn't complain. In the output, what we can see is some meta information of which version of Python I have, which version of pytest, pluggy, I don't know what it is that where it is located, everything is fine. And then it lists all the test files. Well, we have one, and then all the test files that it ran. And then this dot, which is, you can hardly see, but there is a dot, a green dot actually here. That green dot indicates that we had one test function inside this file, and it was passing. Okay, that's what it says. And then here there is a summary of what happened. So far, we actually created our first test. And basically that's it. So I think we are 20 minutes into the presentation. Basically, that's everything, okay? Obviously, we have a lot more. When I'm teaching pytest, it can take 1, 2, maybe even 3 days, depending on how deep we go in and how much time we allocate for exercises and people practicing. But this is the basics. So once you have this, basically you can go out and test anything, right? Because for any function, you can just call the function, give it some input, and get some expected output. Well, not exactly, right? Because for example, if we go back to this website, it's way more complex. Let's say we have managed to set it up. It's way more complex. It has steps. Okay, do this, and then do this, and then do this, and then do this, and then look for some values. Okay, so this is sort of a slightly different style of testing when you have a process of various steps and you want to make sure that you can do each one of these tests one after the other, and then you have some kind of an end result. And so that's way more complex, but again, we are just here at this simple thing. Now, of course, we don't want to have just one test. We would like to have more of these tests. And we also have it here, okay? So we can take this one and convert it into a test as well, assert. And actually, you can see assert is not a function, so you don't have to put parentheses here. And here I'm going to expect, of course, 4. Okay, so now I can run the test, and the result is the same. Okay, it looks the same. It still only has one test. Why? Because pytest only counts the number of functions. Even though we were actually testing 2 different cases, pytest only tests one of the cases. We could have written this slightly differently. We could copy this one and create 2 test functions. So test add, and let's say 2 and 2, okay, just for now. So now we have the same 2 assertions. We are checking the 2 input values, the 2 sets of input values against the expected output. But now if I run pytest, you will see 2 dots. Okay. So why is this good? Why is this one better? And which one is better? Okay, which one is better when we have all these two assertions in the same test function, or when they have in separate one? And sort of the answer is that having them, that you should put interdependent assertions, so dependent assertions, into a single test function. So let's say the test is access this web page and then get some return. And in this response, check whether the header looks this, and there is also this text and also that text. So these 3 assertions, basically, these things that we check, they belong together. So you would probably have all the 3 assertions in the same test function. On the other hand, going further with this, if you're writing a test like what we've discussed here that has certain steps, do this and do that and do that, then these are related and dependent on each other. You can't, the way I explained, you can't test just part 3, okay? You can do that in a different way, but if your test is do this A, B, and C, then they are dependent. They need to be one after the other. So you would put them in the same test function. On the other hand, test cases that are independent, you would put them in separate functions. And putting them in separate functions means that that if one of them fails, okay, the other one is still running. So that's one of the nice things about pytest, that you will have several of these tests. You can have many test cases, and you run them, and 1 or 2 may be failing, but the rest are running, and then you can get the report pointing out that everything is fine except those 2 tests. So that's a very valuable thing, and that's good for a reason to put them separately. But it's also good because you can run the specific test functions on their own. So let's say you have one test which is failing, and now you are working on fixing that code. Instead of running all the tests every time, you can focus on running that specific test while you are trying to fix the code. And of course, if all the tests run like, I don't know, 20 minutes, and one single test runs 2 seconds, then it's a lot of wasted time running all the tests all the time. So it's a good idea to be able to test them separately. Now, actually, I didn't plan on showing this, but let's do it now. And before I do this, git status, let me save this. So git ignore pycache. So we won't have that one. Git status. Yeah, okay, git add, git commit. First example. Fine. Okay, so we have this committed. Now we can continue. And I actually, beyond the fact that I saved it or committed it, I'm also going to copy paste this whole thing, so you won't have to check out all the old versions. So first of all, I'm going to rename this just to test 2 and 3, so we'll have them. and then I'm going to combine them. So let me just have this here and comment that out, so we won't need to deal with this. And now I'm going to show you something very interesting that pytest provides, and this is called parameterization of tests. So I really want to have two test cases, two separate test cases, but they are doing exactly the same, just with different data. Okay, so basically I'm trying to reduce the code duplications, because in this version, right, the one that I'm highlighting, basically I duplicated this calling of the function, which is sort of a waste. So instead of that, I would like to somehow merge these, but on the other hand, I would like to be able to run them separately and have, so I would like to have all the benefits of having separate test cases, but still not writing all the code twice. And for that, I can do the following. Let's say import pytest, and I think it won't like me, right? Because yeah, okay, let me close this and start it again. Hopefully it will remember its size. Oh, it remembered its size. Okay, so I had to rerun it, and it still won't do what I wanted to do. Sorry. Source when being activate. I have to start the virtual end before I start editor. So now in this case, it will already see the pytest because it sees my virtual environment. Fine. Now I can add here pytest, and I mark, I think, and param. And here I have to, I have to cheat. Okay, I have to cheat, which is a good opportunity because I forgot to do this earlier. So CodeMaven, this is my website where I'm publishing a lot of my articles about all kinds of things. And among other things, it has an area where I have all the slides that I'm teaching with all kinds of programming languages. And this one is about Python. And I'm going to add this link to some place so you can access it. In most cases, actually, I'm teaching this stuff from slides, or I used to teach them from slides, and only recently started this playing around with code. It's much more fun, actually, but I have to remember things. So these are the tasks testing with pytest, where you can look at the test. And I think the parameterization, it's here. So this is how it looks like. Parameterize, and then I have to give some variable name. Okay, so let's do this. I cheated. Okay, so the parameterization allows me to set up various test cases. And for this thing, for each test case, we actually need 3 values. The inputting X and Y, and these are going to be this X and this Y, and the expected result, which let's call result. Let's call it result, okay? Or let's call it expected result, okay? So these are the 3 basically variables that I'm expecting. And then here let's just look at the example. I can set up, again, the next example is better. I can set up a list of the values that I would like to pass in. So here, I'm going to create a list of the values I'm passing in. So I'm passing in 2, 3, and the expected value is 5. And then I'm also passing in, and for now it's okay. And here I'm expecting to receive the variables X, Y, and expected result. So this way I can set up, and let me look at this again, sorry. Pytest mark parameterize. So I didn't write it correctly, or it's changed, very strange. Mark parameterize. Okay, this is the right way apparently. So let me finish this and so I can explain it better. So what I'm doing here is I can set up, I'm telling it that I'm going to create test cases that has 3 values, each test case. The first test, in each test case, I have 2 input values, X and Y. And in my case, the third one is the expected result. And then I'm writing down the actual test case. I can add the other one. So the other test case we had is this one, where we add 2 plus 2, and we are checking whether the result is 4. So that's the way how we set up the parameterized tests. Then in the test function, we are saying that we are expecting that the test function, the test add function, will be called with these 3 parameters. And these are the 3 variables that we have here listed here in this string. And that's just a string. Okay. Inside, we can use these variables x, y, and expected result. And we don't need this anymore. Okay, let's see what happens now if I run this pytest. So pytest, the result looks very similar to what we had earlier. It has 2 dots, right? It has 2 dots because we have 2 test cases. As if we really had 2 test functions, but in reality, we only have 1 test functions. But because of the parameterization, pytest called it twice. This idea of having these variables here and then someone else or something else calling the function and providing these values is called, at least in this context, it's called dependency injection. So what we are saying here is we are creating a function that is expecting 3 parameters. And we, who are writing the code, we don't code the function, but instead of that, pytest will look at this function, say, this function is expecting 3 parameters, so let's provide the 3 parameters. Where does pytest get them from? Well, it's listed here. Okay, it says it's listed here first with this, and then with this 3 parameters, it will call the function. But how do I know that this is really what happened? Well, first of all, let's try to use this pytest with -v. -v says verbose. So instead of, in addition to showing, or instead of the 2 dots, it actually shows us each one of the test functions that were executed. And you can see this is the text function. In the test file, there is a function named test add, and then in square brackets, we get the actual parameters that were passed in. So you can see that these were the 2 test functions. Actually, I can show you something different. Let's say we changed it and say we are expecting actually 10. Okay, obviously this will fail. And this is how it looks like. So first of all, you can see that it says it ran the 235 and the 2210. So it was running different functions. And then you can also see the report about the failure that says, okay, there was an assertion where one side was 4 and the other side was 10, and go figure out what happened. Okay, but this is basically the way you can see errors. But that's not what I wanted to show at this point. I wanted to show you this, that I can set up these test cases. And then what I can also do, and let me keep just the -v for now, I can mark this one, well, copy paste. Oh, if I could see what I'm doing here. Paste, I think, yes, okay, good. And now I'm actually running, okay, it needs the second square bracket, okay. I didn't copy paste properly. So what I did now, I said pytest, and then I provided the full name of the test case, which is the name of the test file, the name of the test function, and because this is a parameterized test, it's also the full name that was created earlier, as we could see. This way, I can, basically I'm telling pytest, to run only this test case, this specific test case, and not all the others. So, well, we solved this issue that we now have only a single test function implemented, but it actually is called, in our case, twice. We can go now and copy paste and have more of these. Okay, let's add one more here. -1, +1, and that would be expected to be 0, right? So if I run pytest, -v, now we have 3 test cases. And this, the actual parameters might be a little funny, especially if you have negative numbers or non-negative numbers. That might not be totally clear here from the reading of this one, but that's just a side effect of these names being generated by pytest from the input data. But this way, it's very easy to add a lot more test cases once we have the implemented more cases to implement a test case. Good. Any question? So let me save this now. And parameterize. Okay. So let's go further. Well, one more thing here. So here, what I wrote import mymass, but I could have also wrote in from mymass import add. Of course, this is some other way to use this module. So the fact that I imported mymass this way doesn't matter. You can do it in any way you like. And then, of course, if we are importing this way, then I'm going to call the add function here instead. So then I will call the add function here instead of the mymass.add. So it's just any way you can do it. Any way you could use it in regular Python code, you can use it here as well. Okay, that's not very special. So let's go on with our mymass library and extend it with something very interesting. Well, let's add the multiply method. So multiply. Nothing very interesting in this. I just created a multiply function, and I don't care about the use, implementing the use anymore. I can just add a test case for that. And let's just copy paste this one and add test, call it multiply, and we don't have the parameterization for now. We just do one really simple one, multiply, and it will be 2 and 2, and 2 times 2 is 4, and that's good, right? Pytest. Everything looks fine. Pytest -v, it tells me it ran the 4 test cases, so 3 times the test add and then the multiply. I can also just use this one, and oh, it is so small. I can just run pytest and paste this one, and then I just ran that one. So far looks good, right? And at this point, let's say you send out this module and someone will complain, right? Someone will complain that the multiply function doesn't work always correctly. For example, if you give it 2 and 3, it won't give you back 6 as you're expecting. So what can you do? You add a new test case. Well, if it was parameterized, it would be different. But let's say multiply with 2 and 3. So let's get back to that one. So multiplying 2 and 3, and we are expecting it to be 6, right? So we are running the test, and this indeed fails. Now, if you looked carefully, if you paid attention when I was doing this, basically, I copy pasted the add function, and I didn't change the plus sign to multiplication, to the star. So if I fix the code, I can fix the code and run the test again, and now everything is passing. But that's sort of boring. That's not, you're not that interested in fixing the code, right? So let's return this to the plus and see what else could we do. So again, I ran the tests. I added the test that people were complaining that thing fails, and the test now fails. And so let's see what's going on. First of all, we can see, let me do this without a -v, just pytest. First of all, you can see that we have ... and an F. So this F indicates that this test case fails. Now, this is the last one because in the test file, this was the last test case. But if I put physically this test multiply, let's say at the top, not even, no, let's not put it at the top. Let's put it in the middle, okay? In the middle there somewhere, and I run pytest, the output will show that the F is here, which indicates that although the failing test was in the middle and it failed already, pytest was kept running, as I promised you earlier, and executed more tests, so you can report all the test failures and successes. So in this case, you can see this F indicates that test case failed, and here you can see the actual failure. You can see what was the test case. You can see the actual actual line that failed. You can see the left-hand side is 5 and the right-hand side is 6. Now, I'm saying left-hand side and right-hand side and not actual and expected values, because the order of these two parts, so which one is the expected and which one is the actual result, pytest doesn't care about it. In my case, in this case, on the left-hand side, we have the actual result that the code actually returned, and on the right-hand side, we have the expected result. And personally, I prefer that to be this way all the time. But pytest doesn't enforce any of this. It only complains about the fact that the two are, well, in this case, not equal. It only complains basically that this expression is false. So we have to know which one is the expected side and which one is the actual result. So here we can see the result, and from this point we can check whether we can go to the source code, and well, first of all, we have to verify that our test case is actually correct, okay, whether the expectations is correct, because you remember a couple of minutes ago I changed the expectation to 10 and the test failed, obviously, but then in that case the test was incorrect, right, because the expectation was incorrect, not the actual code. In this case, we know that this is the right expectation, and then if we go back, we can find that what is the bug. And you can fix the bug, but again, that's sort of the boring version of it. The interesting case is when you, for some reason, can't fix the bug. For example, because you have many of these bugs, and you can't fix all of them immediately. So you have a test function. You have added a test case, right? We added a test case because someone complained, okay, or someone came up with this idea that maybe try to multiply 2 by 3, and so we have a test case which fails, and we maybe have many of these reported by on various parts of the code base. So we have a bunch of tests which are failing. So how can we deal with this if we can't fix all of them? And let's focus on this specific one that we can't fix. So we can do a couple of things. Either we can go ahead and say, okay, this test is failing, so let's just comment out, not have the test case running, so all the tests will pass. Sort of, that's fine, but that will easily lead us to forgetting about this relatively quickly. Okay, so there is a better solution or there's another solution. The other solution is to keep the test there with the failure. The problem with this is that if you have many of these failures, every time you run the test, you actually have to check why is something failing. And then you will have to remember that this failure is because A, and that failure is because B, and so on. And we're not fixing all of them. And this is just a huge burden on anyone looking at these tests. And besides, if you have any continuous integration environment that would run the tests all the time, those environments will fail if there is any test failure. And you don't want that, because you want to have your CI system passing the test all the time. And if the CI, the continuous integration system, fails, then you would like to immediately fix the problem. That's the right strategy to work CI. So there is a third or fourth, or I don't know how many already, way that allows us to sort of enjoy all the worlds. And this is marking this test as expected to fail. Well, until we actually fix the code. How can we do this? In order to do this, we have to also import the pytest library. And just let me emphasize here, because I saw a couple of people failing or misunderstanding this. The only time you need the pytest imported if you are using some kind of these decorations. In the first case, when we just wrote some test cases, we didn't need to import pytest. We just run it on the command line. And that might need another clarification. So pytest, the word, is both a command line tool and also a Python module that you can import to do all kinds of things. So the word has double purposes. So here is the test case that is failing, and I can go and mark it with pytest, mark, and I think it's called xfail. And here in the xfail, I need to, let me check if I can see it here, give a reason. Okay, there are all kind of parameters here. I don't know, reason. So basically, this is the excuse. Okay, this is the explanation. Why is this failing, or why are we not fixing it? And here you can say management told us not to fix it now. Okay, you can put it this way, or maybe a better way is to put here a link to the bug report that was the whole cause of adding this test case and all these things. So if it's a Jira ticket, then put in the ticket number. If it's a GitHub or GitLab issue, then put in the ID of the issue. Whatever. Let's say issue number 42. Okay. You can have both in case you want to do something with management. So now if I run pytest, this is the output. So you can see that it's greenish with a little bit of yellow. And you can see here that instead of the failing test, which was a capital F earlier, now you have a lowercase x in yellow, because it's sort of not that good as green, but not as bad as red. So what it says, and here you have it says that 4 tests passed and 1 is X failed, meaning the test failed, but it's okay because we were expecting it to fail. So the test was executed and it was verified that it failed, and that's fine. So this is a way to mark a test case that is known to fail, but you don't want the whole system to every time report that failure. Oh, it's still failing, it's still failing, it's annoying. Now, all the CI systems are looking at the exit code of the pytest program. And if you echo $?, this is how we can see the exit code on Linux or or Mac OS. On Windows, it's called error level, but this is 0. So meaning the test passed. So that's it. The CI system won't fail. You will have this one. Now I can also run pytest -v. And here you can see that it says it's an X fail test. And you can also see the XQs we had. We can also say this one -RX, I think. And this will, what will it do? So it will show the failure, the details of the failure. The test still passes. So if I check the exit code, it's still 0. So that's fine. But because I told it to, I think R stands for report, and X is saying that report the X failures. And you can have various of these R flags that will report various of these special cases in pytest. Okay, what else? Ask me some question in the meantime while I'm drinking. I was talking too much, maybe. That's why you don't have any question now. Okay, no questions, and I'll just keep running. But feel free, again, if you have any questions, just thought about something. Just ask it. Oh, and something else. I just remembered. I keep forgetting this. So if you go to the Codewave and if you go to the announcement of this event, at the bottom you can see that it's free. And it's free because several people are sponsoring me, basically, through the GitHub sponsors or Patreon or through PayPal directly. So if you like all these workshops and all these things, and you feel that you would like to contribute a little bit financially, then this is the way to do it while we are at it. So let me get back to the presentation. I have a couple of more things that I wanted to show, and then we're going to wrap it up, because I think we already have covered quite a few things from the basics of pytest, and you can already do quite a few things with this. Let me check my notes, what I wanted to show you. Well, let's go on with this one for now. What happens? Okay, so everything is nice that we have marked this test to be expected to failure. But what happens if we actually fix the code? So someone comes and actually fix the code without fixing the test, without marking the test to be expected to pass. So I'm running to pytest, and now you remember this was, I don't know if unless you're colorblind, okay? But now it's yellow. Earlier the line was green. Actually, we can see it here. It was green because that was the most important thing. Here it's now yellow because there is something fishy. It's not totally bad, but something is fishy. What is the something fishy? Is that we have a test that was marked as we are expecting it to fail, but the test actually passed. Let me check what is the expected exit code. The exit code is still 0, so the CI system won't fail. I mean, the code itself, right? It's just better. It's not broken. It's apparently the test hadn't caught up with the improvement in the code. We can also see that now it's a capital X, not a lowercase x. So it sees that, okay, there is an expected test which actually passed instead of failing. And let me see what happens if I run this pytest -v. It says the X pass, okay, and I think if I go back, earlier it was X fail, right? And now it says X pass. Where is it? X pass. Okay, so because the expected failure passed, that's how it reports it. And if I run it with -RX, then we don't have, of course, the error. It's nothing special here, I think. Okay, so but eventually, if someone fixed the code, then probably we'll have to remove that the marking from the test that it's failing, right? But let me set it back so it will keep failing, because that's how we like it. Okay, git add failing xfail. Okay, and then the last thing, I think what I wanted to show, well, we can actually we can do also something else here. So I mentioned, right, I can still show something else. I mentioned that if I run this, it will run all the tests, right, regardless the fact that some of them failed. Let me see if this works actually with xfail. I can provide a -x flag, and it tells pytest to stop on the first failure. Now, I'm not sure that this is actually does anything special when I mark the test failure. And indeed, it doesn't do. Okay, so let's go back to the case. Let's try the case. So let's comment out now this one. Okay. So now it's not marked as test failure. If I run this pytest as it is, then it will report that it failed, but it will keep running. Okay, so it will run further and run all the test. But if I run it with -x, then you can see that after the F, there is no additional dot, because the -x test tells pytest to stop immediately after the first failure. And it can be useful if you have many failures and then you want to run the tests, well, not all of them, but at least to the point where the first fails, and then deal with that. Okay, so that can be useful. One note here, actually, I went to a lot of companies and introducing testing. And the interesting thing is that I go to a company, they don't have any tests, nothing, and then I show them how to write tests. And some people really hate it, of course, because they sort of are expected now to do this as well as all the rest of the code, all the rest of the implementation. And so they feel that now they have extra work, and they were okay without this, and why do they need this? And some people really fall in love with this. And I will get back to the first part in a bit. Some people really fall in love, and then they start writing tests, but they don't really know all the things yet. And so what they create lots of tests, and some of those tests run really, really long time, 10 minutes, 20 minutes. And that's usually not a good idea. And why do these tests run a long time? Because they are running on a lot of data. And in some rare cases, you really need all that data in order to verify something. But in most cases, we could actually reduce the data to a very small subset to verify a certain part of the functionality of the program. And then the test would run fast. So I experienced quite a few times that I will go to a company, 0 tests, I teach them how to test 1 day, 2 days, then 2 weeks later I come back to visit them, and now they are complaining that the tests are running slow. It takes an hour for the test to run because they added lots of tests, and some of them are really, really slow because, again, the huge data. So you have to be careful when start adding tests to make sure that the tests actually run relatively fast. And then, and we won't go into this now, you can actually use the same thing, pytest mark, to give sort of names or categories to the tests. So you could mark some of them as long-running tests, and then on your computer, you would, let's say, by default, run just the fast ones and let the CI system run the long ones, because that's just, okay, whatever, later it will do. So that's something that you have to pay attention to. Let me enable this one now. Right. And then one more thing I'm going to show you now, because I put it here in the notes, but we are already at the 1 hour mark, so I'm going to finish it soon. But let me just show you that one. So let's create another function which is called Fibo, which is the Fibonacci function, and it doesn't even have to be Fibonacci. Let's do something easier. Factorial. It's easier. So what is factorial? Factorial would say that if n equals to 1, let's say, then return 1. And I'm going to do it now, equal. Otherwise, return n times factorial n minus 1. And this is just one of the rather stupid examples I use for showing recursive functions. It's stupid because that's not really the way you would implement factorial. You wouldn't use recursive function here. But I have a little point showing it, and probably there could be better examples to show this without using this recursive factorial. So let's test this for a second. And before actually I run this, the pytest, it's passing all the tests. Very nice. So let's test the factorial. Test factorial, and assert my math factorial, let's say 2, that should be equal to 2, right? I think so. And yes, it's passing, everything is fine. But what happens if I try to run factorial, let's say -1, okay? What should be the result here? If we actually call factorial with -1 right now, it will, we can even run this and see what happens. So we got an exception actually. It says recursion error, maximum recursion depth exceeded. Python actually protects us from unlimited recursions. And what happened is that because I gave it a negative number, this stop condition was never met. And so the factorial recursion never started to roll back and return some data. So it will just keep calling factorial. And it was a very deep recursion. And Python has a limit by default of 1,000, more or less. Apparently, it's 969 for some reason. I don't know. But it's sort of, actually, it's 1,000, but it counts all the depths. So not just the recursive call. And apparently, there are some 30 function calls in pytest till the point where we are actually calling the factorial function. So apparently that's why we have 969 here. In this case, the recursive when n is minus 969. So what should we do? Not as a tester, as an implementer of factorial, because this is clearly not a good idea. I mean, someone might call the factorial function and with a negative number. What should we do in that case? We still, the right way or the common way, well, one way would be, okay, at the end it's arbitrary how we decide. One way would be saying, okay, if n is less than 0, then return 0. That's fine, okay? I don't know if is this any correct answer here. I mean, in some cases, in some functions, this might be the right answer. But in this case, I think it would be better to raise an exception. I mean, this factorial was called with an improper input value. And this is also an exception, but this is sort of showing that the person who wrote the code the factorial code didn't really deal with the special case. So it's not showing properly that the caller of factorial wasn't providing the right value. Okay, it seems that the error is inside factorial. So instead of that, I would like to raise here an error and say raise, and let's say value error. Okay, and factorial needs a positive integer was given, and this is n, and then this is going to be an f string. Okay, so this is the exception that I'm going to throw. Let's run the program now. Okay, so indeed we got this exception, right? But now the test fails because we got an exception. So what can we do here? But actually, if you have some code that is actually expected to raise an exception in certain conditions, right? Now this factorial is expected to raise this exception if the user provides a negative value. So now this is sort of, let's call it the API of this function, or the definition of the function. If you give it a positive number, 3, whatever, it will return the factorial of it. Actually, I don't deal the n equals 0 here. That's a separate story. I could fix it. I could say it's 0 here, but whatever. Let's not take care of that now. Okay, let's deal just with the negative numbers. So you know what? This way, it will solve that problem as well. On the other hand, it won't solve if someone provides a string, or if someone provides a floating point number, it's still not fully aware of the world, but fine. So, but now this calling, the exception is part of the definition. So we would like to ensure that this exception happens and the correct message is received. How can we do that? Well, we can write a test. Actually, oops, what did I do? I don't know. Okay. First of all, no one complained, but I had this function twice, factorial negative number. It should have some different name. And then I can write this. So the basic would be try MyMess. I don't need to compare it to anything except value error, ERR, and why is it complaining? I don't know. I don't know why is it complaining. Error equal to, oh, I don't know how to do this now. ABC. Value, oh, I have a typo. Thank you. Okay. And this one, oh, I need to put in SER. Okay, almost. Yeah, I got tired after an hour of talking. Okay, good. Let's see. PyTest. Okay, so and I need to put here assert. So how can I get the text of this? Can I get somehow the test? I don't know. I wanted to compare it to the actually the text. Okay, so I wanted to compare the text is correct. Well, I can't show you. I don't know how to do this manually. So let show you the way it's suggested in PyTest. Dot text, you say? Dot text? No. Dot. No, I don't know. I don't know. Okay, but so
maybe the trace back.
sorry.
We can use the trace back, I think. Trace back that something.
Yeah, yeah. But I don't really want to show this. I wanted to show you the proper way. I just wanted to show first a manual way. So the proper way would be saying with pytest dot raises, and then you can put here the type of the exception. You can say, well, you can say exception here, SERR. Then we call the MIMES factorial in this case. And here, now we have the ERR, and we can interrogate that ERR. We can ask if the assert ERR type, if the type is value error. Okay, so basically we are catching here all kind of exceptions. I don't care, but then we're checking whether it was a value error, and then we can also check maybe the earlier we could have used as well str err value. Okay, so basically I don't know why do I need this str. Let's try this one, str value. Okay, let's check first this one. So this is passing, okay, because we got a value error. And then this is failing because it says that on the left-hand side, we have a value error and the text. And on the right-hand side, we have this ABC, which obviously will fail because that's not ABC. But I can use the str, and probably I could have used it earlier as well. I didn't think about that one. Okay, just to convert it into string. So now it says on the left-hand side, I have this long test of factorial something. On the right-hand side, I have ABC. And actually, it's here. On one hand side, I have ABC. On the right-hand side. On the left-hand side, I have this long text. Okay, so this is what I really need, right? So let me copy paste. And this is our expectation. Now you saw me actually cheating again. What did I do? I ran the test. It failed because I sort of was expecting the incorrect text, copied the actual text that I received and said, well, if this is the error, then it must be the error. And so now I have a case where I'm verifying that if you are giving -1 to factorial, then it will raise a value, it will raise an exception, a value error, and the third is that and this is the text of this error. Okay, so this would be the test. So you can add more of these, of course, and now we could also see what happens if, let's say, someone changes the text here. Just add an X here, just so you can see the difference. And now it says, okay, the text changed. The exception test. Right. So I think I covered, well, everything that I planned to cover for today. There are quite more things to do with pytest, but actually we covered quite a lot of ground. But I would like to say a final note about what we were, what we just experienced here, something that, and this is the key thing I think for testing, that maybe I should have started with it, but it's important to say. Many people think that these automated tests, the primary goal of these automated tests is to check whether now, if I have a bug now in my code. But that's not really the real value of these tests. Okay, the real value of these automated tests is that we can rerun the same test again and again and again. So if I have a test, a bunch of tests that they should all pass, right? Because everything is absolutely fine in my code base. And now I'm going to make some changes to my code base. Maybe I'm fixing some bug. I'm introducing a new feature. I'm introducing a new bug, whatever, okay? So I'm doing something with the code. I'm just refactoring the code. Let's say I'm just refactoring the code. Should not change any behavior. How can you verify it? Okay, in the old times, when you were manual QA, you would ask the manual QA, okay, now check the whole thing again. Obviously, you won't ask it because it's too much work. So they will only check a little part of the code of the application. And so you don't know about the most part of the application if it still works. If you have automated tests, you can just rerun all the tests. Okay, it should take you a couple of minutes, maybe an hour if you have really a lot of tests. And then it verified that everything that worked earlier is still working. And that's the main value of it. And many people call basically this regression testing, though some people use the word regression testing is to when you actually had a regression, so actually broke something that was working earlier, and now because of that you're writing a test for it. That was sort of, I think, the old idea of calling something regression test. In reality, every automated test, the main goal of most of these automated tests is to verify that nothing breaks, that there's no regression in the system. Everything that worked earlier is still working. And so this is basically the main goal. So don't worry. People keep worrying that, oh, I'm writing tests and I can't, they don't find failures. It's fine. The main goal is to let you, the developer, and the whole company at the end sleep better, because you know that a lot of things were checked by these automated tests. And of course, the extent of how much you were testing the system will impact your ability to sleep well. But basically, that's the idea. If you have very few tests, it won't have a huge impact. But if you cover most of the code base with tests, then you can know that you invested a lot and you know that everything that you checked works fine. And if later someone complains about some error or some bug, you will add that test case and you will know that that thing won't happen again because the test will fail. And I think with that, I'm going to finish this. Now, after the video, you can stay around. We can have some discussion if you like, or you can work on some of these things. I can give you some assignments here, some exercises from the slides if you like to play around. You can actually pick something very relatively basic to try to figure out how to do. For example, there are all these relatively simple libraries like JSON and YAML and CSV. So you can have a JSON file and check whether the various functions of the JSON library, the regular Python JSON library, if they work fine. Okay, so you don't have to test your own code to practice testing. You can also test all kind of these standard or non-standard libraries, whether they work properly. That's it. If you're watching the video, and even if you were here, then once I publish the video, please go to YouTube and thumb up and like and whatever the video, follow the channel, turn on the bell so you get notified, join the Code Mavens meetup group so we'll be notified there. And thank you very much for coming, and see you next meeting. Bye-bye.